We're looking at part 1a, and in these we have rational equations that we're trying to solve and identify the restrictions on the variable. So in this first example, number 1 here, you'll see that we have almost the same denominator all the way across, but not quite. And because we're doing addition or subtraction, in this case addition, what we want to do is get ourselves a common denominator. And since I have an n squared and an n squared and an n, I need to multiply this by n on top and bottom, and now it's over n squared. All of my denominators are the same. But here's the magical step. Whenever you have an equation, this is unlike an expression where we don't have an equal sign. An equation does have an equal sign. When you have that, you can multiply both sides of an equation by the same thing. So in this case, we can multiply this side of the equation by n squared and this side of the equation by n squared. And what that does is that cancels out that denominator. Here you distribute that n squared to this piece and to this piece, and what it's going to do is it's going to cancel out both denominators. So effectively what we just did is we rewrote this problem to be 1 plus 1n equals 5. We really could have just crossed out all the denominators. Now mathematically there's really no logic to that, so that's why I wanted to go through what we're actually doing. We're actually multiplying each side by this n squared. But we have 1 plus 1n equals 5. So then we have a simple problem. We just subtract 1 from each side and n equals 4. Now it says something about restrictions on the variable. That's your excluded values. And so our excluded values that make the denominator go to 0. And in all cases, if we set n or n squared equal to 0, we can square root both sides and n is going to equal 0. So we're actually going to want to say not equal to 0. And there we've identified our restriction. So let's do one more example. Let's go down to number 3. Now in this case it gets a little tricky because we have both subtraction and we have a plus sign within the fraction while we have minus outside. So first things first, you know how I feel about subtraction, so we're going to turn this into adding a negative number, and to make this negative we're going to take this entire top, which happens to only be one number in this case, but if there were two numbers up here you'd have to distribute that negative to both. So plus a negative 1 up on top there. The other thing is I need to get 5 and an x in all of my denominators. So I have 5 times x here, so that means I need to multiply this by 5 and thus my top by 5, the entire top of that fraction. Multiply this one by 5 and the entire top of this fraction. So now if I clean this up, I have 10 equals 5x, and I'm distributing this 5 here, plus 15, and then I have minus 1, or plus a negative 1 on top. And on bottom I have 5x, 5x, and 5x, so because I multiplied both sides by 5x, or I can do that, I can pretty much cross those out. So now let's finish this off here. If I'm going to show my work, I guess I'll move that down here. And I need to combine these two, so I get that down to 10 equals 5x plus 14. Subtract that from both sides. Negative 4 equals 5x. Divide both by 5. And x is equal to negative 4/5. Again, going back to our restricted values, what's going to make 5x equal 0? It's going to be when we have x equal to 0. And what you're going to find with these is anytime you have x by itself in the denominator with no plus or minus, your restricted value is going to be that x cannot be 0.